Welcome to this video lecture on the subject Optical and Microwave Engineering. So in this lecture we are going to discuss about directional couplers. So a directional coupler is a 4-port device which is used in microwave frequencies. It is used for coupling a known fraction of power into a coupled port in the auxiliary line. So where the power flowing from input to output port in the main line. So auxiliary line is used for power measurement purpose. So the remaining port is ideally isolated port and matched terminated. They can be designed to measure the incident and reflected power and standing wave ratio. So these are the properties of directional couplers. With matched termination at all the ports, the properties are a portion of power traveling from port 1 to port 2 is coupled to port 4 but not to port 3, and similarly portion of power traveling from port 2 to port 1 is coupled to port 3 and not to port 4. So as shown in this picture, main waveguide consists of port 1 and port 2 and auxiliary waveguide consists of port 3 and port 4. So performance of a directional couplers. So performance of parameters are coupling factor, directivity and isolation. So coupling factor is the ratio of incident power to the forward power. It is measured in decibels. So the formula is 10 log of P1 by P4 or 10 log of Pi by Pf, where Pi is the incident power, Pf is the forward power. And next parameter is directivity. So directivity of a directional coupler is defined as the ratio of forward power to the backward power expressed in decibels. So the formula is 10 log of P4 by P3 or 10 log of Pf by Pb. And next, isolation is defined as the ratio of incident power to the back power. So it is given in 10 log of P1 by P3. And next is the two-hole directional couplers. So two-hole directional coupler consists of two main waveguides, primary and secondary, with tiny holes in between them. The two holes are at a distance of lambda g by 4, where lambda g is the guide wavelength. Fraction of the wave energy entered to port 1 passes through the holes and it is radiated into the secondary guide, as the holes act as a slot antennas. The forward waves are in phase regardless of the hole space. So these waves are added at the port 4 and the backward waves in the secondary guide are out of phase by 180 degree. So they are cancelled at port 3. So port 3 is remains as the isolated port. Port 4 is the coupled port. And we can obtain the scattering matrix for the directional coupler. So where we use the properties of S matrix. So here the directional coupler is a 4-port device. So it consists of a 4 cross 4 matrix. So S matrix is written from S11 to S44. So we are going to apply the properties of S matrix. We use diagonal elements S11, S22, S33, S44 and make all the 4 elements as 0. So all the 4 ports are perfectly matched. And next is the symmetric property. So we can write the reciprocal property where Sij equal to Sji. So we can write the elements S1 to S21 are equal and S23 and S32 are equal and S13 and S31 are equal. So similarly we can write the symmetry elements. And next we are going to derive the S parameter values by using the above property. So there is no coupling between port 1 to port 3. So these two elements are 0. And similarly for no coupling between port 2 and port 4. So S24 and S42 becomes 0. So by substituting the values we get S matrix as 0 S12 0 S14 and it continues. So next we are going to apply the unity property of S matrix where we multiply the S matrix by complex conjugate of the same and we get the equation to identity matrix. And by equating the R1 C1 to 1, R2 C2 to 1 and R3 C3 to 1, we get 3 set of equation. where we solve these three equations to obtain S11, S12 and S23 and S34, and we get the transmission factors and the result of S matrix is 0P 0JQ and it continued. So let's take the assessment. First question, power dividers and couplers are microwave components used for power division and power combining. So the answer is A, it's a passive component. And isolation of a directional coupler is a measure of power delivered to the uncoupled port. Thank you for listening this lecture.